Experiment 6. Aim to determine resistance of a galvanometer by half deflection method and to find its figure of merit. Apparatus: a galvanometer, a battery, eliminator, one resistance box of 0 to 10k
omega,
one resistance box of 0 to 200
omega,
to one-way keys, connecting wires and sandpaper. Theory: a galvanometer is a device which is used to detect small electric current in a circuit. It is a very sensitive instrument and gives a large deflection even for a small value of current. It
works on the principle that a current-carrying coil placed in a uniform magnetic field experiences a torque.
A galvanometer has a moderate resistance, 100
omega,
and has a very small current carrying capacity, 1 mA. The resistance of the given galvanometer as found by half deflection method is given by and shown in figure 6.1. G equal to Rs by R minus S, where S is the shunt resistance and R is the resistance connected in series. Here shown by Rb with the galvanometer, when resistance R, say 1000
omega,
is introduced in the circuit, the current Ig flowing through it is given by Ig is equal to E by R plus G. K2 is open, 1. E is EMF of battery and G is resistance of galvanometer. If theta is deflection in galvanometer, then Ig proportional to theta. Ig is equal to K theta, where K is figure of merit 2. From equation 1 and 2, E by R plus G equal to K theta 3. The figure of merit of a galvanometer is defined as the amount of current required to produce a deflection of one division in the galvanometer. It is denoted by K and can be found by the experimental arrangement shown in figure 6.2. By definition, K equal to I by theta, but I equal to E by R plus G implies that K equal to E by R plus G theta 2, where E equal to EMF of battery, R equal to resistance offered by Rb, G equal to resistance of galvanometer, theta equal to deflection in the galvanometer. The maximum current that can pass through the galvanometer is Ig equal to Nk, where N is the total number of divisions on the either side of 0 of the galvanometer scale. Procedure: resistance of galvanometer by half deflection method. Draw a circuit diagram of the experimental arrangement as shown in figure 6.1. Remove the insulation and clean the end of the connecting wires with the sandpaper. Make the connections as shown in figure 6.1. Check that the plugs of resistance box are tight. Introduce a resistance from the resistance box R and then insert the key K1 only. Adjust the value of R so that the deflection in the galvanometer is maximum even in number and within the scale. Note the deflection, let it be theta. Now insert the key K2 too, and without changing the value of R, adjust the value of S such that deflection in the galvanometer becomes exactly half the value obtained earlier in step 6 as shown above. Example: theta by 2. Note the value of resistance S. Repeat the steps for 3 different values of R and adjust the value of S likewise. For figure of merit, take one cell, find out its EMF with the help of a high resistance voltmeter. Let its EMF be E. Make the connections as shown in figure 6.2. Adjust the value of R to obtain a certain deflection, theta, say 30 divisions, when the circuit is closed. Note the values of resistance R and deflection Q. Change the value of R and note the corresponding deflection theta again. Repeat the above steps for both the cells of the battery. Find the figure of merit K by using equation 2. Observations and calculations.
Record all the observations in the following table and calculate the values.
Result:
Precautions.
all the connections should be neat, clean and tight. Ensure that the plugs in the two resistance boxes are tight. Initially, a high resistance voltmeter should be used to measure the EMF of the battery, otherwise the galvanometer may get damaged. Sources of error: the screws of the instruments may be loose, the plugs in the two resistance boxes may not be tight, the galvanometer divisions may not be of same size, the EMF of the battery may not be constant.